Hello class, we will be working in a close proximity to hot furnaces, hot samples, and tools that can get hot from contact with hot samples. Okay, we will also use a hot air gun, and due to these conditions you need to include some additional PPE requirements for this lab specifically. In particular, list of PPE, look at the screen now. You'll be able to see that we have closed-toed shoes along with your safety glasses, some long pants such as jeans, gloves, which we'll provide you in class. We have two pairs in particular. The first pair here, these are for the oven and specifically, and then these smaller, less thick pairs, those are for handling the hot samples over at the lab portion. In addition, make sure that if you have long hair, you have it pulled back, and that you've removed any jewelry that you might have that could dangle into the surface and be a hazard. As an additional precaution, we're going to introduce what is known as a hot zone, which is going to be the area near the furnaces. And in this zone, we're only going to want one person is going to be allowed. Only one person is allowed in the hot zone at a time. This provides that one person enough space to place samples in or out of the furnace, maneuver, and place samples on trays for cooling without worrying about accidentally hitting someone else in the hot zone. To give you an idea of where that's approximately at, we have our two furnaces here, okay? And then approximately here is where our hot zone boundary is going to be from the entrance point of view. That way, don't get too much closer than here. We give the person who's at the furnace enough space to take the samples out and then put them on the trays. In the case of a serious injury, such as a severe burn or even a minor burn, make sure that you've read the instructions ahead of time so that way you have the contact information ready to go in case you have a serious injury. For this lab, we're going to have some equipment needs. In particular, you can see that we have our two furnaces, 1, 2. The furnace on the left is the set furnace where you're able to control it with just a set point. And then the furnace on the right is one that is controlled by the computer, where we're going to be able to program in a more advanced heat treatment cycle rather than just having direct control over a single set point temperature. In addition to both of these, we also have a set of tongs, that we can use in order to take our sample out of either of the furnaces, so that way we're not burning our hands or grabbing it directly with our gloves. In addition to the tongs, we're also going to have some pliers. So we have the large set. We also have some additional small pliers that we have available. And then we also are going to have our cookie trays. Okay. We also have our cookie tray where we're going to be able to take our samples out from the furnace and place them onto the cooking tray, so that way we don't have to handle the sample or the heat treat envelope bag directly, which will be hot. Okay. And in addition, we also have some heat treating bags. One thing to note, when we're looking at our heat treat bags, you'll see that they'll be wrapped up and they're nice and shiny. These are some of the unused heat treat bags. And in general, you can see that we have a larger bag. Those tend to be better for your low carbon samples, which will fit into it and need that extra height. And then we'll also have some smaller bags as well, where those smaller bags will be better to fit our A2 samples in. Okay, and so just make sure that as you're doing your heat treating, you select the appropriate bag for whatever sample you need. Alrighty, we're now ready to prepare our samples and to put them into the furnace. And so what you want to do is, like, you have our sample, and then you're going to want to make sure that you're using a fresh bag. So for example, if you see a bag like this one is used. You want to make sure that it's one that's nice and shiny and it hasn't been used before. Okay, and then you're going to want to take the samples, put it into your bag, okay, and then you're going to want to press it flat, and then you're going to want to roll it up so it looks kind of like this, and you'll notice how it's been rolled up. Okay, do be careful, this is metal and it can give you a paper cut or a metal cut, and it is sharp, so do be careful as you're wrapping them up. And then once you have it wrapped up, what you're going to want to do, if your furnace is cold, you can put it in with your hands. However, if our furnace is hot, we want to make sure that we put on our gloves. Okay. Typically, you'll want to put your samples in cold. All right. But if it is warm, you take your sample, and then we can use our pair of tongs to grasp our samples in the envelope. All right, so that way it's in the envelope and it's prepared for heat treating. And we can open up the furnace and just gently place our samples in. All right, and then you can close your furnace. And then if you haven't turned it on because it's already cold, you can go ahead and turn it on. And then you can use the appropriate controller, whether you're using the furnace with the computer, and so you'll need to use the computer to control it, or if you're using the second furnace, where you need to control it manually with the buttons. Okay? Once you've put it in, you can take off your gloves. Alrighty, now you can watch the segment on programming with the furnace. You might be wondering why we need to use the heat treating envelopes. The reason is to protect the steel from oxygen during the heating process. If an envelope or some other method such as flooding the furnace with an inert gas is not used, then what will happen is the steel will oxidize and it will change its chemical composition. To keep the chemical composition the same, we need to prevent oxidization, and since these furnaces do not have a way to flood them with inert gas, we are going to use those heat treating envelopes. Operate the furnace, this one it's helpful to remember that while this handle will open it, you'll see that there's a little bit of slack here. If you try to just pull down on it, it's not going to open. That's on purpose. If you want to actually open our system, you need to take the lever, pull it up, and then bring it down. Okay? And that will allow it to open. And then you'll notice that after you bring it back, you can take it and push it back in, and that keeps it nice and locked tight and secure. Let's take a look inside of our furnace. We'll be able to see that inside of our furnace, we can see that we have our insulation all the way around on the sides. You can see that there is this metal bed. That's where you're going to be able to place your samples. And then back here, and you can see up here, that is our actual temperature gauge. All this white stuff is a lot of insulation. And if we take a side perspective, all the coils on the sides are the resistors where we're going to have the heating. Next, let's explain the parts of the furnace. We're going to start off by using the furnace on the left. So this one is the furnace which only has a set point. So it does not have the more advanced programmatic control with the computer. To turn it on, you're going to go ahead and hit the power button here. I'll turn it on, and then if you press it, turn it off, you'll notice that the power button lights up. And then we can see over here on the right hand side we have 27. So what this is it's saying that our system is currently set at 27 degrees. We can see that the cycle is flashing as it's figuring out if it needs to turn on. In order to see what the set point is, we have to press our control buttons once, and we can see that it flashes over to 25. So that's saying that our set point is currently set at 25 degrees Celsius. Okay. In order to change what our set point is, we can press the down, or the up arrow. If we press it once, we can see that we get our set point. It eventually goes back. If we press it once, and then we continue to press, we can see that our set point will now change. And I'll go ahead and set it up to approximately 100. Oops. And it is a little bit finicky, so it's okay if you have a little bit of trouble changing your set point. And so regardless, what we can see is that since it is heating, you'll see that the cycle button has been lit, and you can see that our temperature is now increasing, and it will eventually get up to 95 degrees or 96 degrees, which is our set point. To explain those controls again, we can see that we have our temperature. Our current temperature is 87. To see what our set point is, we press either the down button once, and you can see that we're currently set at 98 degrees, or we can press the up arrow once, and then we can see that the set point is 98. To change that set point, we have to press and then press and hold, And we can see that we can change it up or down as we desire. I'll go ahead and set it lower so you can see what it looks like. One thing to note is the up button is a little bit finicky, so using the down button can be a little bit easier for programming purposes. Alrighty, now that I've set it beneath our set point, you'll be able to see that, if we zoom out, be able to see that the cycle light has turned off. That's saying that our system is no longer applying heat. You'll see that the temperature is going to rise a little bit more because it's going to take a while for the temperature inside of our furnace to equilibrate. All right. In addition to the set point furnace, we also have our programmable furnace, which is over here on the right hand side. It has a similar looking control scheme, and we'll notice that we can turn it on. Now for this one in general, we're going to want to use our computer in order to control it. Alrighty, now we're going to the computer in order to control our system. We'll go ahead and click on iTools Engineering Studio. You can see that it's bringing up the Eurotherm application, and we're able to see our system now. With this, we can see that we don't have anything going on. What's happening is we don't have what is occurring is that our hardware is not picking up the controller. In order to find it, we need to scan for it. Now you can hit the scan button. All of these default settings tend to work. Notice that we have to connect via CPI clip or IR cable, scan for Eurotherm devices only, and then it can terminate the scan when the first device is found. Go ahead and do that, select OK. And you're going to pay attention to over here, and you're going to be able to see that we have a com4.id and then some other numbers followed by that, and then you can see that it is synchronizing. After that has gone away, we now have it by itself, where we can see that we have now also lit up the access button as well. What this means is that we now have all of our options for setting up our system. With all these options in place, what we're able to do is set up our timer feature, so that way we can change what the settings are for our system. Now there's going to be two ways that we can do this. The first is by selecting on the timer folder directly. However, a more straightforward way and a little bit more graphic is to use the wizards. You can go ahead. This is saying that we can't run it if we are in the wizard. So we'll go ahead and select yes. See that this is going to load our wizards. And then now, once it is loaded, we can see that there are many options we can select. However, we want to go ahead and select the timer option. Okay, and you'll be able to see that this has brought up our program. Okay, and you can see that we now have our options available to us, where we can have the different set points, the rate to get up or down from that set point, and then the soak times that we have. I'll go ahead and put in our demonstration one, which is going to be for one of our steels. We're going to want to anneal it, and so we're going to want that at 885 for that first set point, and then we want to ramp it up at a rate of 250 degrees Celsius per hour, and then we're going to let that soak for 30 minutes and 0 hours. Okay, and then we also have a second stage for this one, where we bring it down to 650 degrees Celsius at a slow rate, so 28 degrees Cs per hour. And then we want to let that dwell for 15 minutes. All right. You'll notice that I've left the remaining two entries blank. All right. The reason we've done this is so that way we don't have these for our next system. Once you've done that, you don't need to worry about hitting next or back. Just go ahead and hit close. Hit OK. And then we go over to our timer feature, and you can click it. You'll see that this has brought up all of these settings for the timer, where we can see that some of those parameters we put in the graphic version with the wizard, we can now see their application in the different timer target set points, ramp rates, and dwell times. And so you can see where our first set of parameters, and then for our second set of parameters, and for the ones that we left 0, you can see that they're set at 0, and then they're turned off as well. Lastly, we can go back to the top and we can see that we have all of our different systems, and then you'll notice that the timer status is set to 0 currently because it is not running. In order to run our system, we're going to have to change the axis and toggle it off. All right, and you should have been able to hear when you click that axis, you would hear the relay click off or click on. And if we look at our controller, we can see that it's now set, it's showing in the lower part of the controller. We can zoom into our controller. We can see that the top number is showing the current temperature inside of our system, and then the bottom is saying it is off because our timer is set to off. Now, in order to turn it on, we can go and see that timer status button. We go ahead and click it, and we can hit run. And as soon as I hit run, you can see now we have the timer running. And you can see in the lower system, we have the 26. So that's the ongoing set point for the timer. See that it has the run button. That's saying that a timer is running, and you can see the words flash on the screen. And then you can see on top, that is the actual temperature inside of the oven. The average that is the instantaneous temperature inside of the oven. Now I'll go ahead and turn it off, so that way we can set up some of the other systems. Now you can see that I turned it off. You can see that the cycle is no longer going, and we now have our controller set to off as well. Alrighty, for the second part, we want to make sure that we're also recording our data as we're running our heat treatment cycle. This is particularly helpful as you look towards your projects, as it can provide some additional insights into what you are doing and what it actually happened in terms of the heat treatment cycle versus what you plan to happen for the heat treat cycle. Overall, this should be something that you'll only need to worry about for the purposes of the project. Now to record the data, you can go ahead and select OPC Scope. And you can see that this brings up another menu for us where we're going to be able to access any of our default data. Now, the easiest thing to do here, rather than searching through everything, is you can click Open, and you can go to Desktop, and then Temperature Data, and then you can see there's Annealment 1, and you can go ahead and click Open with that. This will terminate your current one, that's okay. Hit Yes, and then we're going to be able to see two values in our chart, the first being the different COM values, where we have a PV in value, and then a working SP value. Going over to the list, what we're going to be able to see is that the working SP value is the set point that the system is set to, and this will change as a function of time. So this is the ideal temperature of our system in terms of its set point, where we're changing it with the ramp going up or down. And then the other value is 32.93, and you can see all those digits. You can see that that matches up with our controller as the actual temperature of our system. Okay? Now, by recording both of these, we're going to be able to see that now, as we go over to our original system, and we can turn it from status, and we now turn it to our run status, we're going to be able to switch back. And we can see that our system is now running, and we can see that we have it going. However, it is not recording the data. How do we record the data? In order to record the data, we need to start the data logger. And then this will let you record it. We'll go ahead and put this into our folder, Engineering 314 Data Records. and we can hit save. And as you'll see, that will save our CSV. And then now we can see over here on the right hand side, we have our system where we can see its temperatures. We can modify the chart axes by clicking on the little chart button, and you can see with these axes, and it's set to 3-day time span. We can zoom into 1 hour, 2 hour, 6 hour, something reasonable. Since it's only been running for a couple minutes, we'll change it to that. And then we can see that we have our system, which is up at about 33 degrees, whereas our set point is down at 25 degrees or so. Okay, and now you can see that our ramp is starting to run. We're going to now see changes in our temperature. Okay, and we'll give it a minute or two just so that way you can see some data being recorded. Okay. In terms of how often the data is recorded, that's with this stopwatch icon. And we've set it to 60,000 milliseconds, which is basically once a minute. That way we don't have too fast of a sampling rate, and you can record your data for a couple hours, if not like a day or so, without filling up everything in the system. All right? Alrighty. I'll let that run for another minute or two. Now I updated the sampling rate just to give us a quicker imaging and being able to see a quicker update on the two values. And you'll see that the orange is the working set point, so that's what we want our system to be at. And then the blue line is the actual temperature inside of our system. And so you'll be able to see that there's going to be that small difference between the two values. And though ideally it should be within about a degree or two at most as we go up in temperature. Alrighty, with that being said, after this is done, you're ready to go and let the system run. And then you need to come back whenever you need to take the material out of the furnace. And so we'll go ahead and time lapse to that portion. Good luck on the assignment. Alrighty, now that the samples have annealed or they've finished tempering, we're ready to take them out from the furnace, and we're going to be taking them out of the furnace hot. Okay, and so we want to make sure that we're prepared to do this. Make sure that the hot zone is completely cleared out and there's only one person. That'll be the instructor when we're doing the annealing examples. But when you're doing your project later, that might be one person in your group is ready to go with the gloves on and the tongs ready to grab the sample. Okay, and we need to work quickly but carefully. All right, and so I'll go ahead as a procedure. We'll take it out of the furnace, and then we're going to have a cookie sheet, all right, ready to go to hold our samples. All right, and so the students will hold we'll go ahead and have this cookie sheet, and I'll just go ahead and have it placed over here. So that way nobody's holding it, and I can have a clear place to place it. I have a clear spot to place the samples before someone grabs them and takes them over to the workstation to air cool the samples. Alrighty, so I'll go ahead and grab them out of our furnace. Notice that I'm using the tongs, so that way I'm not close to the system. And I'll grab the bag, and I'll place the bag onto the cookie sheet. Alright, now that it's out of, and then I'll close the furnace as well. Alrighty. Now that I've taken them out, we're ready to air cool our specimens. Now we've just taken our sample out of the oven. We want to provide some air cooling to it. All right, and so the way we're going to do that is using a heat gun. And so this will help to cool it quicker, as we're going to have forced convection instead of just free convection. But it's also going to provide a second thing in that the heat gun will provide hot air rather than providing cooler air just from the surroundings. And so what we can do is we can use some of the settings on our heat gun. For example, if we look at this setting here, if we turn it to the positive side, all right, if we take our heat gun, we turn it counterclock, if we turn this setting counterclockwise on our heat gun, that's going to increase our heat, all right, whereas if we turn it clockwise, that's going to decrease the heat of our heat gun, all right? And then we can see on the back here, we have different settings, and so we have 0, that's because it's off, and then I'll go ahead and turn it on. You see there's the 1, it's a low fan speed, and then 2 is a high fan speed, okay? All right, now I'll put my gloves back on so we can handle our sample. And what we're gonna wanna do is we're gonna use our heat gun, we'll turn it on, and then we're gonna blow it across our sample. However, we wanna make sure that we're doing well and evenly cooling our sample. And so what's gonna be best is if you or someone else in your lab group is using the pliers to hold the sample bag upright, okay? So that way you can cool both sides of your sample. All right, does that make sense? And then one thing to do is you can use the tray to balance it, and then you have one hand holding your sample, second hand holding your heat gun. You can turn your heat gun on, and then you can hold it, and that way you're providing, you hold it like this, okay? And then that way you're blowing on both sides of your sample, okay? And so you can think about some of your heat transfer and fluid mechanics for why you would want to do this. I'll go ahead and demonstrate that for us. Alrighty, after doing this for several minutes, we should be able to see that the temperature of our sample is decreased. If you're not sure if your sample's warm or not, you can use a couple of methods. One is to do the is it hot method, okay? And the second is a little bit more quantitative, where we can use an infrared gun. And so as we can see, if you click the gun, you'll see that it pops up and it shows the temperature settings over here. And so we can make a measurement of our sample, and we can see that this one is down at just about 24 degrees Celsius because I didn't actually put this sample into the oven. And so this would be very much safe to the touch. All right. The second method, if you don't have a IR gun ready, is to very, very carefully use your hand as a heat sensor. Now again, this is being very careful. If you touch a very hot piece of metal with your fingers, you will burn yourself. So you don't want to touch it. Instead, you can use the back of your hand, which is actually more sensitive than the front of your hand in terms of heat sensing. And it's also a little bit less risky in terms of if you get a burn here, it's going to suck a little bit less than if you burn the tips of your fingers or anywhere on the front side of your hand. So using the back of your hand, you can, and usually it's better to put your sample down so that way you don't accidentally bump yourself. But you can carefully bring your back of your hand close to the bag. The goal is not to touch it. You should not touch it. But what you're trying to sense is you don't have any forced convection going on. And so you have some free convection. And you want to see if the air surrounding the bag is warm. Because if the air surrounding the bag is warm, guess what? The bag itself and the metal inside of it is going to be even hotter. And so you're not going to want to touch it. And so you can very carefully bring your hand in contact. If you're bringing it relatively close and you're not feeling much heat, then you can do what is known as a quick tap. And that would be just like that. The point there being is that with a very quick tap, you're going to minimize, if it is hot, well, you will come into contact, you'll feel that heat, but then you'll remove your hand quick enough that you don't cause a severe burn. Okay? That being said, if you're not comfortable using this, that is fine. Just use the infrared gun if you have any doubt about using your hand, the back of your hand as a temperature sensor. But you can use the back of your hand in like more everyday settings such as, oh, is this pot of water hot or not? Well, you can use the back of your hand as a quick sensor for when the temperatures are more moderate in your everyday life. Once it is ready to go and your system has gotten to a cool to the touch part, right, where you're able to touch it, but maybe you're not able to really hold on to it because it's really hot, then it's ready to come outside of the bag. And so there's a couple ways. One, if you feel very inclined to do so, you can use your set of pliers to hold onto your bag at different points, and then you can unwrap it Okay. The second is to just simply go ahead and use a pair of shears and cut open the bag. Okay. Once you've done that, you're able to now use those samples, and then you can continue cooling them with your heat gun, where you can then turn your heat gun setting down until it is on not providing heating anymore and is only passing through room temperature air to continue cooling your samples until they're comfortable to the touch or they're at room temperature. Once your sample has gotten down to room temperature, then you're good to go, and you're able to now use them for the next stages. So that would be for testing or whatever material characterization stages we have next. Thank you and good luck.